Hello everyone, welcome back. My name is Dr. Trengo Anderson Gaji. Again, like I say, you can call me Tren or Dr. Tren. We will be picking up where we left off. First off, let me stop this cam. Okay, so in the last video, in the last session when we stopped, we did the metrics, and this was very high. So we're gonna go ahead and resolve that. So let me scroll up here. So this should be mean absolute percent, I think percentage error, mean absolute. Let's run that again. It's not defined. Okay, now let's see. Oh, that should be percentage. Now let's run that again and see. Okay, now that's more like 8. Okay, good. Now, since we have 7 metrics here, I'm going to have to do the same thing in the previous regression analysis that we did so that we will compare this. I will take a snip of this and then paste this somewhere so that we will compare them. Okay, so we're going to have to keep going up. Okay, so this was where I copied. This was the first analysis that I did, but it was missing some key matrices that some key metrics, that I did earlier. So I'm gonna have to adjust this. To do that, I think maybe I need to go down and copy and paste up. Sorry for taking you guys back and forth. Let me just copy everything here. Uh, don't worry. I will adjust as I paste up. It might take some time. It might, but it's worth it. So let me see. Where was I? Up here. Okay, here. Just gonna AV. Except that here I will change this back. Anything 3 dot way moderation, I will delete it back because we want to compare results that are similar. So that looks good. I copy and paste is good, but sometimes it can also be a pain if you forget to maintain consistency. So that is good. Now let's check back down here. Delete that. Good. Delete that. Good. 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 That. Okay, so now let's run that. Uh, cannot access variable WordPress where it is not associated with a value. Let's just run all. Run all. So it's definitely top to the bottom. Let's see. WordPress data. I guess I'm just gonna copy this here. Sometimes when my eyes glaze, I don't see very well. That's funny, but that's okay when you're sitting on a computer for some time. Now let's see. So why Pred? Probably I forgot to delete all of this Y Oh, there it is. Perhaps that's where the problem is coming from. So now let's run that again. Pred. Any 3WM here? I don't see any. Define. Okay, in that define function, there should be something in there. That one right there. Okay, don't worry, we'll get there. One thing, if you're coding, don't feel bad if you're making mistakes or you're making errors. It's part of the process. It's normal. Okay, so now I'm gonna say here, let me change this to model performance evaluation metrics for multiple regression, for regular multiple regression, for uh, yeah, multiple regression, right? And prediction. For prediction without interaction variables, let me see. There should be a right term for saying that. For prediction without interactive terms. Without interactive terms. I think I should put it that way. That should be better. So let's run that. But in this case, I'm going to change this to, let's say 69. Let me, aesthetics is important. Oh, let me just say 77 then. 79, 79, 79. Around that. That's better. Okay, now I will say, I will copy this same thing here. Before I do that, before I go that far, let me stay right here. I'm going to pull up an Excel and then copy this here for our interpretation, okay? That will help us. Now let me put that here. Then I'm going to go all the way down. Oh, up here. And then here I will say for prediction with interaction terms. So let's run that again. So actually, let me run it all because I don't know if it's going to pull up based on the data that's up, all over there. Let me just run that or run it all. Yep. Perfect. Uh-oh. I should have changed this to 79. I'm going to have to repeat that run all again. Sorry, guys. Now again, run all. Perfect. Now let me bring back my Excel. Copy that over here. Paste it over here. At this point, let me save my work so that I will not lose it. Came this far, right? Okay, now let's bring back the Excel file. Now, remember here, the model without interaction that was not re-engineered, that without interaction terms, that is, let me just say non-engineered model, non-engineered model. This is it right here. Let me just think a line. Center across. That should be that, and then let me bold it. B. This one right here. Let me color code that as yellow. I want you to see this clearly so that it will help him what I'm saying, what I'm doing. Let me just copy that here. Copy and then paste here. Here let me change the color to maybe something like that one. Here I would say that model with interaction terms. I'm just repeating that for emphasis, even though it's already on the header in these snippets, but I will explain now. Okay, now I want you to, first of all, let's look at what is here. As you can see, let me just start from bottom up, okay? For this one, the R square is 35%, right? The R square here is 38%. That means that this model performed better in terms of accounting for variability, okay, of the criterion variable. Again, R squared does not indicate that how well a model performs only. No, that's not what that means. Many people do that mistake. It does not tell. It tells us how well the model fits in terms of explaining the variance in the criterion variable or the response variable or the dependent variable. So that is what that is telling us here. So clearly, this is I'm going to go with 38% than 35%. Also, the R square adjusted here, the adjusted R square is 35% versus 38%. So again, this is better. Okay, now let's go upwards now, and then I will start interpreting from top to the bottom. So for the MAE, that is mean absolute error of 4.9, they look similar. 4.98 here, actually 4.99 here, and then 4.96 here. It means, again, this is lower than this, so slightly lower, but that is okay. It means that on the average, this model, this model accounts for above or below. There are some units that are above or below the insulin prediction. This, which is kind of like moderate accuracy. Now the mean absolute percentage error is 61% here. Same thing here, 62%. What that's telling us is that the prediction is on the average about 60. Let me just interpret on this side, 61% away from the actual values. This is kind of high, to be frank. Same thing, kind of symmetric mean absolute percentage error is supposed to be an improvement of the MAPE, but it is also high. For the non-engineered model, it is 45%, while for the engineered model, it is 44.6%. This is kind of like still relatively high. This indicates that on the average, the predictions differ from the actual values by 44.69%. The same thing applies to this side, 45.35%. They are both high. Now, for the mean squared error, for the non-engineer, the model that has non-interaction terms, we have about 57.7 While on the one that has the model that has the introduction terms has 55. So that means that on the average squared error is has higher errors that are penalized, which is suggesting more uh, individual prediction errors. Yeah. Now for the root, again, it is not good to only use mean squared error. Is I would recommend always follow it up with the root mean squared error. So for the model without the introduction terms, we have 7.599, and on the one with the introduction terms, we got 7.42. Okay. Now, what that is telling us is that the typical prediction error is about on the one without the interruption time is about 7.6 uh, uh, insulin units away from the prediction, and this value is interpretable in the same unit as the target, variable. That is the response variable, the criterion variable. For the R squared, again, just like we are explained earlier, this is lower and this is higher. So I'm going to go with this model here. If I'm to choose what model I will use, I would choose this model. Let me just expand it and so it will cover that all of them. I would choose this model here. Yeah, this is better than the other one. So this is how we do a model and then try to fine tune it by introducing interaction terms. Some people will use different approaches such as random forest, regression, or support vector regression, but I will not do it in this series. I would do it in another series. I would run regression, regular regression, and then do SVR, and then do random forest, and then compare the three of them to see. For now, I'm just going to keep it simple. So thank you for watching my video. In my next video, I will try to use Power BI to bring in the data that we have downloaded and then try to make some visualizations and see after this insight that we have gotten from this analysis. Thank you and have a nice day. Bye.